Hello and welcome. My name's Alistair Leith, and I'm just about to walk for a brief kind of What's Up in a Night Sky podcast with you while the kids are at school. The wife's popped out. Perfect conditions to record this, other than the fact I've got a bit of a cold. So if I do appear to pause or clear my throat from time to time, please excuse me. But this is about the best I'm ever going to be able to get for peace and quiet. So keep with me, and hopefully I'll be able to walk you through what's in the night sky from here in sunny Northampton, which will also, plus or minus a couple of degrees up and down the country. It ain't going to change too much, so this will still be valid to you. So here we are, we're in Northampton, 9th of February 2015. The time is 15:08. And once again, I'm Alistair Leith. I run the Online Astronomy Society Academy and the Online Astronomy Society itself, and this software is Starry Night. If you Google that, it's a very good planetarium program, and it's not free, but I prefer using it because it's so versatile. And I'm using this for purposes of the podcast. Anyhow, I started off at about roughly. It's not exactly dark at that time. Let's go a bit darker, around about 5 o'clock, 5:30. But that's late enough. If we look over here to the west, you can see a very bright object in the night sky there, and a lot of people have often confused Venus with UFOs and aircraft and things. Please get inundated with phone calls because they think they've seen something. Venus is very, very bright indeed, and the reason for that is it's got a very thick carbon dioxide atmosphere, and as a result of that, it's a big victim of the greenhouse effect. Something which we are falling victim to, and if you want to get an idea of where we could be going, look at good old Venus over there. About the same size as Mother Earth in size, we're just a tiny tad bigger, not much. I mean, if you compare this to two cue balls, whoever the top snooker player is would be happy to play with both balls. They look pretty much the same size, only we're a bit bigger, but not by much. This is our sister planet over there. As I say, Venus has got what we call very high albedo. Albedo basically means the planet's reflective power. So the higher the albedo, the more of the sunlight it's going to reflect away. The lower the albedo, the less of the sunlight it reflects back away. So Venus has got a high albedo, and so there's another planet we'll be discussing shortly that's rising just as this one is setting. For a small telescope, I looked at it the other night through my 8-inch Schmidt-Cassegrain telescope, and I couldn't make out very much. I mean, the conditions that low are quite poor, to say the least. I mean, keep in mind that we've been sort of in the sun, the atmosphere has been heating, the warm air is still rising as the cooler air is beginning to, as the air is beginning to settle into the night. But there's still pretty sort of warmish, in the twilight day there, which is why you see an awful lot of sort of bubbling when you look through the telescope. And if the moon was there and you magnified the moon up, it would look. You couldn't focus it. It'd be like the effect of trying to look through. I'm overcomplicating matters here, but let's just put it this way: it'd be very hard to see any details of Venus at all, because of the amount of turbulence in the area. I tried 2 nights running, took a video of it, didn't show too much, didn't really do much more with it, which is sad because, I mean, you can see phases of Venus. You'll never see it as full Venus, but you'll see it going down the phases from there. And it's interesting if you can resolve it that well, that you can sort of see how the size of the planet changes with each capture. But a friend of mine managed it with an 8-inch telescope, same size as mine. With a smaller one, you might just about make out the phase if you're using higher magnification. But that would be a bit. Filters might bring out some atmospheric detail, but other than that, I mean, it's a good object. And if you've not seen Venus before, just want to say, oh, hey, look, that's Venus. It's another world over there. Nice little party trick for the parents, for the family, for the girlfriend, for the boyfriend. But there it is, Venus over there, and of course it sets pretty early. It doesn't stay up all night because it's closer to the sun. It's the second one in that one, and it's also incidentally the hottest. If you went there, far from having a nice warm summer's holiday, which the Victorians believed you would be literally suffocated by the CO2 atmosphere, you would be crushed by the immense pressure, and you'd be dissolved as well by sulfuric acid. The same stuff you find in your battery, in your car battery. So that's what Venus would hold for us if we ever went there. So beautiful to look at, but don't visit. But there we go. That's Venus for you, very high in the western sky at the moment, coming close to sunset. So what other beauties do we have? Well, if I pop in and sort of look kind of westerly now, let's go from our sister planet to the giant king planet, which is kind of just about rising at about now. It's still sort of below the horizon, but as the sun sets, Venus, well, Jupiter, sorry, will rise. Let's go ahead by an hour or so. Around about 7 o'clock, it's sort of about as high in the east as Venus was in the west there, and there she is. Jupiter is quite bright. It's the brightest object in the night, other than obviously the sun, the moon, and Venus. You can't really mistake it. I mean, it's as bright as it comes. Also, a big albedo to it because it reflects an awful lot of light away that the sun hits it. And through a pair of binoculars, you can see it. You might just resolve the moons. Let me just grab a little drop of water here. But through a telescope, you will most certainly see the moons, and there's 4 of them, which you can particularly see. You've got Io, Europa, Ganymede, and Callisto there. And those 4 moons move on a regular basis around the planet. And even if you don't get to see much of the surface detail of Jupiter itself, it's nice to see. Let me get rid of this there. It's nice to see the overall, how the moons move. And one of the things I've been having a bit of a play with, and there's no reason if you've got the same kit you can't as well, and that is if you've got a small telescope, take a look. You'll be able to see the belts of Jupiter. You'll be able to see the equatorial belts, north and south, that are both there, and be able to see the planets better too. But if you've got a webcam, and they're inexpensive these days, you can pop it in, and on your laptop maybe take, say, 1500 frames every 10 minutes, and then you can sort of see over time how those moons do actually move. So again, you don't need a massive telescope to see that, but still it's certainly worth taking a look. And obviously with a bigger telescope, well, I'm sure that most of my audience don't own one of those, but then you can start seeing what we call transits, which is when the moons will move over the actual surface of Jupiter and cast a shadow. But we're looking at probably 8 inches and above of aperture for a telescope, to show us that. So I'm going to try and keep to the lower sort of leagues of optics there for the purposes of these. So that's Jupiter for you, and as I say, certainly well worth getting a webcam onto that and seeing what you can see. A focusing tip for you is to be careful, because the conditions of the atmosphere mean you can be in focus 1 minute and out of focus the next. That's not necessarily down to your optics, that is down to the instability and the turbulence in the atmosphere. And unfortunately, when objects are low in the sky like that, you're going through far more atmosphere, which means the planet's light's going to come through a lot more atmosphere than it would do normally if it was higher up, which means it's got all the turbulence to go through, which means it's not a straight line that comes straight away from outer space to your right. It's been refracted up, down, left, right. It's been played with a bit by the time you get it, which is why sometimes it's nice and reasonably crystal clear, and other times it's not. And the moon plays the same game as well when you're at higher magnification. So keep that in mind. But that's Jupiter for you, and again, certainly well worth taking a look. And because it's just come out of opposition, means it's directly opposite the sun with respect to where we are, which basically means that Jupiter rises as the sun sets, and Jupiter stays in the sky until it rises. So it's there pretty much all the way through as it goes across the sky there. So Jupiter's certainly worth taking a look at. Something else certainly worth taking a look at, and I'm going to quickly wander across to that, is Orion. There we are, Orion. There she is, the 7 stars down the way here. There's Orion. It's Orion the Hunter, and that's the main part of Orion. There you can see Orion's arm extending out. There's the bow, and he's wielding something up here as well, and basically he's trying to kill the bull that's over there, and is accompanied by his 2 dogs, which if I could turn the settings easy on and off here, I'd certainly show you, but maybe I'll look to do that next time. But again, Orion, for me, it is my most favourite constellation in the night sky. There's literally something in that for everyone. One of the things is it's a great object to recognise. It's probably about the size of your fist if you hold it up in the night sky, maybe a bit smaller. maybe Ophista's a bit smaller, but this is a massive constellation. And if you like polluted skies, you will not fail to notice these 7 stars right there in the south. Take a look at it. There it is. It's the highest, about the highest it's going to go. Might go a bit higher, but there she is. For me in my garden, I've got a tree about here, which means I've got a few degrees of viewing time. But I've got, if you're looking with the naked eye, there's a few things you can spot straight away. Up there to the top left-hand corner is what we call Betelgeuse, and that is that's a supergiant star. It's about to die. And if you put that where our sun is in the solar system at the moment, it would gobble up the whole lot all the way up to the orbit of about Mars. And so that gives you some idea of the size of Betelgeuse compared to our sun. I know it's not the biggest star in the night sky either. There's one that dwarfs even that. But that star, we believe, is on its way out. We believe it's at the end of its day. And when it does die, don't worry, it's not going to happen in any of our lifetimes. It'll probably take a few million years yet. But that will leave a kind of a gaseous, we call a planetary nebula. And out of that, in time, other stars will become born. It's how the universe recycles itself. So again, with a pair of binoculars, it'll show us a nice red star. Certainly worth taking a look at. It's a beautiful star to look at. I was looking at it the other night because of another project I'm working on, which I'll divulge to anybody who asks me, but I'm not going to scare people off by saying that I'm an amateur spectroscopist when I'm not running these programs. Anyhow, let's move on. So if we come down next, sort of draw a straight line between here and there, we'll come down to another star, and then if we come to the middle one, I'm not saying what the star names are because I don't want you to try to memorise those while you're listening to me. Any decent star chart will give you the star names. Then if you come straight down from Orion's belt, you then come down to 3 stars that he soared. Well, they're not 3 stars, the middle one isn't anyway. And that is what we call the Great Orion Nebula. And on from our dear planets and the moon, it is probably the most observed object in the night sky. You can't fail to notice it if you've got a pair of binoculars and you sort of gaze in that general direction. But I mean, if you've got reasonable conditions again, and you're looking there, you will see that smudge. A lot of people are doing DSLR work. That's taking pictures with a digital single lens reflex camera, that stands for. And if you don't put it up the prime focus of any telescope, but just take a wide angle view of that constellation, you will see that nebula. It is beautiful. It's also one of the trickiest ones to photograph, as I'm finding out. But if you just want to gaze it, it's beautiful. It's there, it's kind to the beginner. You can see it with the naked eye. If you put a pair of binoculars on it, again, you can see it as a discernible smudge. If you put a small telescope on it, something about 60 to 70 millimeters in aperture, that's the size of the objective, you will see some structure, and not a lot different to the fancy, not a lot different in shape and size to the coloured photographs that we see. And added to the fact it's going to be in black and white, not in colour, because our eyes aren't sensitive enough to pick up that colour. In fact, you've got to look at it with averted vision too, because the rods that are on the outside of our eye are more sensitive to it than the cones on the inside. So you've got to be averted. So look away, then you'll see more structure to it, more of a shape. If you can't do that too well, then just get a pencil, put a rubber on the end, and gently tap the telescope, and then you should start seeing it then. If you're really getting good at that, try sketching it, and I'd love to see the sketches if you want to put them in the main OAS group or the OAS beginners group on Facebook. So help yourself there. It certainly is a nebula worth taking a look at, and if you do have a camera, a DSLR camera perhaps, then by all means, put it at the prime focus of your telescope, and just put it up at the bottom of your telescope, where you'd normally put the eyepiece. There are steps between that. You can't just put it up with the main lens up there, but any questions on how to do that, then contact me. But you can take a decent picture of the nebula then too. But that's getting into another subject. But getting right back to where we are, then what's up in the night sky, the Orion Nebula, very well worthwhile taking a look at. And I think I might have mentioned Sirius earlier on. That's the brightest star in the night sky there. That down there, it's what we call the dog star. and it's unmistakable as well. That is the brightest star in the night sky. Other than that, well, the sun's in our daytime sky, isn't it, to be fair? But that is the brightest star in the night sky. And before I leave you with that, I can't very well give a WhatsApp presentation without looking at this beautiful star cluster here. These are the Pleiades, the Seven Sisters. A good test for your eyesight under dark conditions. Excuse me. How many of those can you see? Now, don't quote me on it, but I think that used to be used as a test by the ancient Romans for their soldiers to sort of tell them how many stars they could see in that cluster, and that was a measure for eyesight. The more you could see, the better your eyesight was. I mean, without my glasses, it's a smudge to me anyway. But with my glasses on, I struggled to see 3 or 4 of them. But then I desperately need a new pair of glasses now. But that object there, it's unmistakable, really, if you know where to look for it with the naked eye. Pair of binoculars will show it with beautiful majesty. This is one of the few objects where putting a telescope on it will actually, in my honest opinion, ruin it. You will not see the entire cluster easily through any telescope, not with mine anyway. But that is certainly worth taking a look at there. So there we are. A few objects available for you to see. We've looked at Venus. We've taken a brief look at Jupiter. We've also taken a look at the Pleiades and M42. So there's a few objects there for you to take a look at and sort of take a few sketches of if you can, and let us know how it goes. Either way, I hope this has been informative for you, and thank you for watching.